Hi, in this video I'm going to show you two examples of limit calculation from the worksheet I handed in class. Okay, I know I've corrected these in class, but I think the video will give you the opportunity to review the corrected problem a couple of times if you need to. Okay, so let's go over the first one. I want to talk about this one right here. This is a trigonometric limit. As x approaches 0, I want to know where the cotan of 2x and the cosecant of x is going, the ratio of these two quantities. Okay, so of course the first thing you have to do is substitute. So let me try that. That's a cotan of 0 and that's a cosecant of 0. Do never forget that step. Never forget that step to substitute. But you know, let's see, what's the cotan of 0? Of course there will be some trouble here. Cotan of 0 is cosine 0 over sine 0. Cosine 0 is 1, sine 0 is 0. Problem, this is undefined. So in my limit, this is actually undefined. Cosecant 0, this is actually 0, so there's a lot of trouble. The top is undefined and I divide by 0 something that is not defined. I'll let you figure out where that goes at this point. So you have to go further. You have to change this expression and you have to do some algebra. Okay, so let's take the expression cotan of 2x over the cosecant of x. And I'm gonna start with something that you should do all the time. Anytime I have a cotan, a tan, a secant or a cosecant, I change it to sine and cosine. I change everything to sine and cosine. Okay, so this is the cosine of 2x divided by the sine of 2x, and this is divided by what? 1 over sine x. Okay, so what do we have? We have cosine 2x times sine x divided by sine 2x. Okay, so what do we do with that? If you plug in right here to find the limit, you're gonna get stuck. Let's try it. So what is that? Cosine 2x, if I plug in 0, I find 1. Cosine 0 is 1. Sine 0 is 0. And the sine of 2x is 0. So here, that's undeterminated. Okay, undeterminated. So here it means that I have to go further again. I'm not done. I have to go further. That was not enough. And sometimes it happens, you know, you start changing things and you still have to go further. All right, so where do we go from now? We have no choice. You have a cosine of 2x right here and a sine of 2x right there. That calls for double angle formula in trigonometry. If you've forgotten your double angle formula in trigonometry, check it out. You can Google it, check your notes from last year, go on the book that you had last year, but these are formula you will find everywhere. Now, the cosine of 2x, there are 3 formulae for the cosine of 2x. At this point, I'm not sure which one I should be using, so you know what? I'm just gonna leave it like that. I don't know what to do right here. We'll see after, okay? So cosine 2x times sine x. It's much better for sine of 2x. There's only one formula. It's 2 sine x cosine x. Okay, well, right away, right here, something is happening, right? Sine x and sine x, they cancel together, and so you have cosine 2x over 2 cosine x. To tell you the truth, the first time I did that, I used the double angle of cosine, but a student in class noticed that you're done actually, because now, look, let's take the limit again. Okay, these were my simplification. Okay, it had nothing to do with limits. Now I'm going back to my limit. The limit as x approaches 0 of the cotan of 2x over the cosecant of x is the limit. Please don't forget the limit. Okay, be careful of your notation. This is like a syntax of the cosine of 2x over 2 cosine x, and that is completely fine. I am not gonna write limit here because I'm gonna take my limit just by plugging in. Okay, cosine of 2 times 0 is cosine 0 over 2 cosine 0, and this is fine because cosine 0 is 1, so it's 1/2. Okay, and the first limit is done. All right, I'll have time in this video to do a second limit, so let's take the second one. this is a little bit more difficult actually, okay? The technique for this one is a little bit more elaborate. So let's try to understand where the difficulty comes from. When I see that, the first thing I'm thinking about when I see that is this: the limit as x approaches 0 of sine x over x, okay? And that is 1. That's the first thing I think when I see that. But then the problem is that's not the limit at 0, but it's a limit at 1. My second problem is that, look, you know, if I had this sine of pi x over x minus 1, if this was a true equation, that the sine of pi x minus 1, the sine of pi x over x minus 1 is equal to the sine of pi x over, is equal to the sine of pi x over x minus the sine of pi x over 1. If this were true, I'd be done. I mean, somewhat, you know. But of course, you know that this is not true, okay? And so, what are we going to do? Well, the main problem comes from that right here, and then another aspect, this one. And solving this problem is also going to solve this one. What do I want right here? I don't want x minus 1. I don't want x minus 1. I want to have a single variable at the denominator, okay? And, sorry, that's not difficult. We're going to do a change of variable. Change of variable. We do that often in math. What do I want? Well, let's call this right here, let's call it u. Okay, u is going to be x minus 1. Well, if u is x minus 1, what is x? If u is x minus 1, x is u plus 1. The symbol stands for if and only if, okay? But be careful, it's a limit. So it's not enough just to say change the variable in the limit. You also have to change the variable, you know, for this thing right here has to change. So as x approaches 1, where does u go? What does u approach? Well, u approaches, let's see, if x goes to 1, then u goes to 1 minus 1, 0. Okay, is that clear? And so with that, now, let's rewrite our limit. Let's rewrite our limit. Our limit now becomes the limit of, as u approaches 0, of what? Of the sine of, you cannot write x in there, okay? X is gone. You're rewriting the limit with a different variable. So it's pi times x, and x is u plus 1. Pi times u plus 1 over x minus 1. Well, that's exactly why I call x minus 1 u, because now I only have u at the denominator. That is just u. Well, okay, I like that. I like that. I like that. It got a little bit messier inside the sign, okay? So we got to do something about that. Well, the first thing you have to do is a no-brainer. You have to expand, okay? So this is the sine of pi u plus pi. Okay, the sine of pi u plus pi over u. And now what? Well, hey girls, now, you know, this is a sine of a sum. And that's PC again. PC and maybe algebra, maybe a geometry, trigonometry. Sometimes this is covered in geotrig, okay? So you can apply the sum of a sum, the sine of a sum. Sine A plus B is sine A cos B plus sine B cosine A, and simplify everything. But actually, this is not the way I'm going to simplify that. I'm gonna think of the sine of A plus pi in a different way. I find it faster and well, yeah, faster and maybe better too. I don't know if you've seen it like that or not. Let me show you how to simplify the expression sine of A plus pi, which, so what do I want to do? Simplify sine of A plus pi. And this, girls, I'm not going to show you that right now, but this would work for anything, the cosine of A plus pi. It would work for any quadrantal angle, okay? The sine of pi over 2 plus A, pi over 2 minus A, 3 pi over 2. I mean, it works at all the quadrantal angle, you know, the angles on the axis. Okay, so how do we do that? Well, first, draw the unit circle. Here's the unit circle. Here's the x-axis and here's the y-axis. This again is the unit circle, okay? let's draw a small, I want to simplify the expression sine of a plus pi. Let me draw a small angle A, and I'll tell you why small right now. Why small? Well, you know, when you work on the unit circle, you know where to see, where to look at the cosine of A and the sine of A, right? The cosine of A is the x-coordinate of the point. This is the cosine of A right here. This length right here represents the cosine of A. And the sine of A is the y-coordinate of the point. This length right here represents the sine of A, right? That's the advantage of working on the unit circle, okay? The coordinate of the point on the terminal side of the angle are the cosine and the sine of the angle, okay? All right, but I want to simplify the sine of A plus pi, so let's now represent A plus pi. Where's the angle A plus pi? Well, it's A plus pi, so it's right across it, right? That's A plus pi. Where is the sine of A plus pi and the cosine of A plus pi? Well, I mean, same thing, it's a unit circle, so the y-coordinate of this point is the sine of A plus pi, and the x-coordinate of this point is the cosine of A plus pi, okay? So, now look, this angle right here is the same as A, right? That's pi plus A plus pi, same thing. So this angle is the same as A, and therefore what do you have? You have that this triangle right here, and I'm going to abuse the language here, this triangle right here is the same as this triangle right here, okay? I should say congruent, or maybe I should say they have the same size. Therefore what? Therefore this length right here are the same right here, and these lengths are the same, okay? But this and this, they don't have the same sign, S-I-G-N, okay? And I have now, I'm able right now to simplify sine of A plus B, sine of A plus pi. What do I have? The sine of A plus pi is equal to, okay, the length right here is exactly the same as that, but they have a different sign. That's it, okay? Let's go back to our limits now. So, this limit is then equal to limit as u approaches 0 of, well, this is my A, okay, A plus pi. So negative sine A, so that means negative sine of pi u over u. And now this is very familiar territory for us. Inside the sine I have pi u. I want to divide it by pi u to apply this formula right here, okay, to apply this formula. All right, but of course you cannot just, you know, at will change what an expression is. You can multiply by 1 though, so that's what I do. And now this limit is here, let's just take our time, let's take the sine out and let's take the pi out, so it's negative pi times the limit of sine of pi u over pi u as u approaches 0, and pi u is approaching 0, so these two quantities approaches 0 at the same pace, I mean in the same fashion, okay, it's pi u and pi u. Therefore this limit right here approaches 1, therefore my limit approaches negative pi. Okay, that's it. I'll do other video for other problems. Bye.